You pecah-pecahkan dia jadi table. Itu saja normalization. Kenapa you perlu buat yang itu? Kenapa you perlu buat? You boleh jadikan dia satu table yang besar. Okay, you boleh buat dia satu table yang besar. Patient registration. Patient registration. You masukkan dalam table ni semua. You masukkan dalam table ni patient info, name, patient info, name, semua tu you masukkan dalam ni. Lepas tu insurance, lepas tu history dia, sejarah dia, history. Lepas tu you masukkan sekali insurance, insurance pun you masukkan sini sekali. Semua you masukkan, you jadikan dia satu table. Okay, kalau, okay, itu yang you buat. Okay, tapi untuk tu, kenapa kita tak boleh buat macam ni? Itu yang normalization. Itu yang normalization. You tak boleh buat macam ni. Kenapa? Sebab dia akan bagi you banyak masa. You kena pecahkan dia. Dengan menggunakan konsep normalization, kita akan pecahkan dia kepada banyak table, entities. Okay? And then kita akan assign dia punya attribute. Kita tak boleh buat macam ni. Kita tak boleh. Yang ini dilarang buat. Tak boleh buat macam ni. Semua you tak boleh jadikan table. Sebab dia akan ada data redundancy dan dia akan ada banyak isu lepas tu. Okay, kenapa? You tengok dekat sini. Normalization process will ensure, kalau ada normalization, daripada normalization table ni, kita akan jadikan dia sub-sub table. Kita tak boleh jadikan dia macam ni. Okay, kita tak boleh jadikan dia macam ni. Kita boleh jadikan dia macam ni sebab dia yang ni akan jadi first normalization. Okay, first normalization. Kita ada step-step dia untuk buat normalize. So yang ini akan jadi first normalization. Kita akan pecahkan dia. Dia ada step macam mana kita boleh pecahkan dia mengikut table-table ni. Okay. So normalization process will ensure good database scheme which is represented by accurate table structure. Okay. That's why I told you, right, you have to divide it into few tables. It ensures good database scheme. Okay. Kalau you boleh pecahkan dia kepada beberapa table, that means kita dah panggil dia a good database scheme, which is represented an accurate table structure. We need an accurate table structure, not only a table, but an accurate table structure. Why? We need minimize redundancy. We want to minimize redundancy. That means repetition of the data. Kita tak mau data itu repeat banyak kali. Itu yang kita panggil redundancy. Therefore, possible anomalies can be prevented. Anomalies is something abnormal. Anomalies is something deviate from norm, from normal. Dia bukan normal lah, dia macam abnormal. Itu yang kita panggil anomalies. Kita tak mau ada anomalies. Okay, kita tak mau ada. Therefore, possible anomalies can be prevented. So we have to prevent. We don't want data redundancy. We don't want. That's why we have to minimize data redundancy. And then therefore, we have to prevent anomalies. That means that anomalies is deviate from normal. Kita tak mau ada apa-apa deviation, perubahan. Produce a flexible database design. Database can be expanded if new requirement on entity set, attribute, relation are needed. So dia mestilah fleksibel ya. So kamu kena tahu satu database tu, kalau kamu nak, kenapa kita perlu normalize supaya kita boleh dapat one accurate structure, table structure, minimize data redundancy, prevent anomalies and flexible database design. Kalau you nak kembangkan dia, katakan tadi tak ada medication kan, kita ada sampai ni, sekarang you nak tambah medication, you boleh tambah lagi dalam database tu. Okay, you boleh tambah saja dalam database tu. You bagi medicine ID. Itu you tambah saja. Kalau ada benda lain you nak tambah, you boleh tambah terus. Itu yang kita panggil sebagai flexibility. Faham tak? Flexible data design. Faham ya? Yang ini you kena faham betul-betul. Kalau tak, you tak boleh nak proceed. Kami lecturer pun nak ajar bahagian ni memang susah. Okay, nak ajar kamu ya, sebab yang ini lebih kurang kamu kena faham sendirilah kebanyakan masa. Macam mana you boleh pecahkan dia kepada table-table ni. Kami akan bagi you step-step, nanti you kena buat sendiri. Okay, so database model, kita kena prevent semua ni. Okay. Kemudian, the importance of normalization in database, sama lah. Improve system and performance and accuracy, same lah. Why we need describe the purpose, so you can read lah, same thing. You have to reduce redundancy, and then integrity, consistency, then minimize, save space, minimize redundancy, eliminate. This is the most important part. This is the most important part that I showed you just now. Save space, minimum redundancy, and eliminate anomalies. Anomalies is something deviate. We don't want anything abnormal. So this is the most important part in normalization. Okay, the rest I think you can read. Anomalies. What is anomalies? Normalization is a technique for producing relation scheme with the following properties. No information redundancy. Sama lah, sama repetition lah. So no information redundancy. Kalau nama tu tak payahlah berulang 10 kali, takkan you nak letak nama dalam semua table ni, takkan nak letak nama. Takkan nak letak nama patient name. Takkan nak letak dalam semua. Takkan nak letak dalam semua. So tak perlu. Satu kali letak name dah cukup, dalam patient info dah cukup. Setiap satu tu kalau kita letak table tu bukan table yang baguslah. It's not a good structured table. It is not a good structured table. Faham tak? Okay. So that's why you have to know information redundancy, no anomalies. Okay. So we are going to see what are anomalies. Anomalies is defined as problem that can occur in poorly planned, unnormalized database. Faham tak? Anomalies saya tak bagi nota lagi nanti saya bagi tahu. Dalam CDOS saya dah letak tapi not updated. Dalam CDOS you boleh ambil nota tapi tak updated. Ingat problem that can occur in poorly planned. So you see what is anomaly? Anomaly definition. Anomaly means problem that can occur in poorly planned, unnormalized database where all the data is stored in one table. Same like I told you just now, like this, like this. You store everything given to you, all these, into one table. Do you like it or not? Is it a good plan or not? No, right?
No.
No, not at all. Not at all. So that's why that's why we want to do normalization. Okay. So normalization database where all data is stored in one table. Okay, so we do want, because when we want to, there are three types of anomalies. So when we have one straight table, patient name, let's say Ali lah. Okay, patient name Ali. So dia ada medication dia semua, isteri. Lepas tu dia ada medication dekat sini. Okay, katakan you nak padam let's say Panadol lah. Panadol hanya di bawah nama dia. Dekat sini ada Ahmad. Okay, Ahmad pun ada Panadol. Mungkin Ahmad ada ubat lain termasuk Panadol lah. Okay, Ahmad mungkin ada ubat lain termasuk Panadol. Mungkin dia ada sirap cough sirap lah. Okay, so katakan you padam Panadol ni, katakan Ali dah tak ada dah, Ali dah meninggal lah. Okay, so you delete dia punya rekod. Panadol ni pun akan delete sama. Panadol ni pun akan delete sama. Faham tak? Panadol ni pun akan delete sama. So dalam rekod ni memang tak ada Panadol. So you kena keluarkan table ni asing. Contoh you kena keluarkan table dia asing. Lepas tu you kena rujuk dia. You kena rujuk dia macam parents, child, like that. You must give it a foreign key, or it could be normally the medication will be a weak entity. Will be a weak entity. Okay, where it doesn't have any primary key. Sometimes lah, it might not have. So it depends. So itulah. I'm just showing you lah one of it. So if you delete one, you see these are the three types of anomalies. If you do not normalize the table, if you do not break it into small parts, okay. Kalau you tak pecahkan table tersebut kepada bahagian-bahagian yang kecil, you akan ada anomalies. you akan ada anomalies di mana kita akan ada insertion anomalies, kita akan ada deletion anomalies, kita akan ada modification ataupun update anomalies. So bila you update, you delete, you modify, you akan ada masalah. Macam tadi saya bagi tahu kan, contoh you padam Panadol, so this one is delete anomalies. I just show you lah. If you don't normalize it, what will happen? You delete Panadol, semua patient dalam hospital tu tak boleh dapat Panadol sebab database dia dah hilang. Okay? Database dia dah hilang. Contohlah. Okay? Itu anomalies. Kita tak mau yang itu. Kita tak mau yang itu. Ataupun you letak Panadol banyak kali. Panadol ada banyak tempat. Nanti you nak update Panadol ni kepada ubat lain, you tak boleh nak update dia. Okay? So itu adalah update anomalies. Lepas tu you nak insert. You nak insert, okay, kita akan lihat satu persatu. So ingat ni problem that occur when information is inserted. So during normalization, kenapa kita perlu normalization? Because we don't want. Why we need normalization? Because we don't want anomalies. We don't want anomalies. We don't want to have insertion anomalies. We don't want to have problem when we are deleting the data. We don't want to have the problem when we are modifying or update anomalies. You understand or not? So we don't want to have any of these issues. Okay, so for this example, they have given tables lah. These are the tables. Actually, this table, then later you will see this is a unnormalized table. Okay, this is unnormalized table. Later you will see we will start normalizing it part by part. Okay. Okay, so we see this is an unnormalized table. So from this table, you see there is a data. You see Azura. Kita tak boleh ada tengok Azura. Also kita ada redundant. Azura 2 kali. Kita tak perlu ada macam tu. Azura sekali sudah cukup. Lepas tu siapa lagi kita ada yang kita tengok? Kita tengok apa lagi? Azura ada lagi dekat sini. Tengok Azura banyak kali. Oh kan table yang sama kot. Table yang sama. Lepas tu dia insert lagi sampai Sally lah. Okay, insertion anomalies. Insertion anomalies ni, insertion anomalies you ada masalah. Katakan table biasa macam table atas ni. Table atas ni kita tak normalize lagi Kita tak normalize lagi. So kita expect table ni akan ada insertion anomalies. Kita anggap dia akan ada deletion anomalies dan kita anggap dia akan ada modification or update anomalies. Faham tak? Okay. So to insert a new record whereby part of it already exists in the table. To insert a new student named Sally wants to register information cost. So kita lihat Sally information system cost. Although details of this course already existed, we still have to repeat this tuple for new student. The value of the attribute, faham tak? Sally sekarang Sally, tadi mula-mula Sally tak ada. Lepas tu kita insert Sally dalam ni. Okay? Tapi walaupun information system dah ada, you tengok repetition, sini dah ada, tapi kita letak juga Sally information system. So yang ini adalah insertion anomalies. Kita tak sepatutnya ada, tu yang saya cakap. Dia tak boleh ada. You tengok dekat sini, Azura pun sama. Kita letak computer science 2 kali. Information system dah ada 4 kali tapi kita masih letak. So yang ini adalah redundant, repetition. Redundant, repetition of the data. Yang ini you tengok, repetition of data. Redundancy. We don't want all that. We don't want redundant. Okay, so you see the value of attribute tuple can be assumed to be null. This is allowed because grade point is not a primary key. You boleh insert tau. You boleh insert sebab dia mana-mana sini, you tengok. Dalam sini course code ni, dia tak jadikan dia primary key lagi. Dia tak jadikan dia primary key lagi tau. Dia tak jadikan dia primary key lagi. Kalau dia jadikan ni primary key, you tak boleh letak ni. You tak boleh letak ni. Sebab tu kita kadang-kadang ada weak entity. Sebab weak entity you boleh letak dia semua null pun tak apa. Okay, faham You boleh letak null semua pun tak apa. You tengok dalam ni, sebab dia bukan primary key, you masih boleh letak null. Tapi katakan you nak semua ni, tapi you tak boleh, you tak tahu lagi, you dah register Sally, you tak tahu course code dia apa, course name dia apa, uni dia apa, you tak tahu lagi. Course code kita tahu kan, IS100. Course name mungkin you masih tak tahu lagi, you nak bagi register dia information science system saja. You nak biarkan ni semua null. You boleh biarkan dekat sini. Tapi ada kalanya you tak boleh ni biarkan. In which few details have not exist yet in the table. Okay, so kalau course code ni dia jadi primary key, katakan can you leave it null lah? Can you ever leave your primary key null? Can you? Anyone? Can you ever leave your primary key null? Cannot. You cannot leave your primary key null. So it will give you error. Okay, so that's what we said. To insert a new tuple in which few details have not exist. You see, this course has no student yet. So this is different course lah. Okay, never mind. I just inform you. If it is primary key, then you cannot put this. Since they haven't declared it as primary key, so you can put it now. So that is also anomalies here. And the second part, they said, you see, unfortunately, this course has no student yet, so we cannot insert it in the table unless, okay, this one they can insert. Why? What they wanted to show you, they can insert Sally. Because, why they can insert Sally? Because the course code is not a primary key, but in the second part, they wanted to insert this course as no student yet, no student. Got no student, name don't have nothing, you don't have name, null. You want to put name as a null, but sorry, name, not name lah, this one as null. Name is not null lah. Normally we don't put name as your primary key, so you don't have any detail. You don't have any detail. You only have course code, course name, and unit. You see, you only have course code, course name, and unit. So you have to fill up here. Let's say you are filling it up, IS100, what else? Not they say new course, right? SE33. So new course SE333. Another one is my laptop hang already. Wait down. Okay, never mind. I will go down and teach you first. Okay, let's say you put in this value, this value, this value, but you do not know the student ID. That means you cannot insert. It won't allow you insert because you already said the primary key is student ID. Okay, you already said the primary key is the student ID. So it won't allow you to insert that. Okay. It won't allow you to insert. That's what they want to tell. That is the difference here. You understand? To insert new record whereby part of it already exists in the table. To insert new record, new tuple in which few data have not exist in the table. So you cannot insert this one. So to avoid all that is where we go, we do normalization. We separate the table. Even this table, one of the tables we will be doing the normalization, okay? And deletion anomalies. Okay, as I told you, delete anomalies in a tuple, in a relation, the other detail that we still need are also lost. Okay, let's say, for example, if we delete tuple for student 4213, where is 4213? Okay, we delete this one, detail of SEE. Okay, you say you delete. Okay, you don't want student ID. You already grad lah. Let's say this one already grad. Cannot pula. Alamak, satu demi satu masalah ni. Beda. Maybe I have opened up so many files. I can't afford to lose any of the file. Okay. Okay, let's say you delete this one. Who's that? You delete You delete 42, you delete 4213 carry. Okay, you delete this one because the student no more, graduated already. Graduated already, but we did not have SEE under anyone's name else. We don't have that subject in anyone else's name. So it will be deleted. Same like what I told you, Panadol. Just now I told you the Panadol, right? If you don't have, if only Ali has Panadol, you delete Panadol, the Panadol will be missing from the database. Dia akan hilang terus daripada database tersebut. Sama untuk ni ya. Sama untuk ini pun. Bila 4213 ID tu you delete dia, okay, that means everything will be deleted. Okay, everything. So you cannot find this course. So we don't want this is what we call deletion anomalies. Okay. Kalau you jadikan dia satu table besar macam ni ya, you akan ada masalah sebab tu you kena pecah-pecahkan dia kepada table. Okay, yang terakhir sekali adalah modification anomalies. Okay, modification anomalies is a condition when we change data value. So when you change data value of one attribute, more than one tuples are affected due to the redundant data. Okay, contoh dekat sini dia bagi apa? Information. If the unit for graduation for information system, you tengok information system berapa kali dia redundant. You tengok dia 1, 2, 3. 3 kali repeat. So ini adalah data redundancy. Dia cakap, katakan unit dia dipindahkan kepada 130, 125 hingga 130. So apa you perlu buat? You kena pergi kepada setiap satu ni, you tukar dia kepada 130, 130. Okay, the value also needs to be modified for all student taking information major. So kita tak mau macam tu. Apa kata kita just buat dekat sini satu lagi table. Kita buat satu lagi table di mana hang baliklah. Kita buat satu lagi table di mana dia akan ada asing. Grade unit ni dia akan ada table yang asing. Okay, so yang tu better. So bila you modify information systems 130, automatically yang lain semua auto update. Dia akan refer kepada table tu. Oh, it is taking this chunk is taking information system. So we know you update only once in a sub table, in one of the entity in the table. That the grade point of information system is 130. So you will only have one information system. You might have another table where go back and come back. Okay. So you have only one table. You have only one table. You will have a separate table for major. Contoh lah, ini yang kita panggil normalization, kita pecahkan table dia kepada grade unit. Okay, kita pecahkan table dia. So table dia katakan information system, grade unit dia adalah 30. Mungkin course code tak payahlah, ini saja cukup. Lepas tu course code pun tak perlu. Course code major, okay major lah. Okay, yang ini computer science. Computer science 118. Kemudian kita ada software engineering. Software engineering 130 grade unit. So apa you buat sekarang, you nak tukar dia. Sorry, yang ini kita biarkan dia kepada 125. Okay, sekarang kalau kita dah ada normalized table ya. Kalau kita dah ada normalized table, apa kita buat? Kita akan tukar dekat sini saja. Kita akan padam ni, kita akan tukar dia kepada 130. Satu saja. Dan kadang-kadang mungkin kita dah tukar untuk ni, kita lupa dah tukar untuk N. Katakan kita terlupa tukar untuk N, so N kena ambil satu subjek atau dua subjek yang lebih untuk dia grad. Faham tak? Sebab kenapa kita tak mau redundancy data? Sebab kita mungkin terlupa, sebab kita manusia, mungkin kita terlupa. Kita update dekat sini, kita biarkan information system. So yang dua ni ambil dua subjek lebih untuk grad. Yang ini, N untung. N masih kekal 125 unit. So dia kurang dua subjek. Okay, so kita tak nak anomalies itu. So kita letak dia asing table macam ni. Okay, so itu yang kita panggil sebagai modification. So bila kita modify satu dekat sini 130, automatically tiga-tiga orang ni dia akan jadi 130. So kita tak akan ada masalah. Sebab tu kita pecah, kita buat normalization, and we don't want all these three anomalies, where we don't want insertion anomalies, the undesirable condition, weird condition or problem exists when we insert a new tuple into an unstructured table. So all this you can read, modification. Any problem so far, class? Class, do you understand or not? You know how many days I've been thinking of the way to make it very simple for you? Because this part is not easy. Every time I teach, my student will always confuse. So I'm trying my best to teach you in a very simple way so that you can understand. So you should know from this table, okay? From this table, we want to break it into few tables like this, okay? That is called normalization, okay? But if you keep on having this whole thing like this, you will have three types of anomalies, okay? You will have three types of anomalies. That is a weird condition happens when you are inserting, and then when you delete one, or the whole thing of that particular database, if it doesn't exist repetition, then it will lose. And then when you modify, you only modify few you forgot to modify. So we don't want all this to happen. Anomalies is something deviate from normal. So we don't want anything these three to happen. That's why we are doing normalization. Any questions so far, class? Pagi-pagi I dah buat lecture kan? Susah untuk you orang. Sekejap. Semua dah ada ke? Tak ada. So masih I ambil attendance lagi. I bagi orang break 5 minit. Nasrul belum ada lagi. Nasrul. Kenapa Nasrul lambat? Tertidur. Lepas sahur. Ini Tenarasan dengan Rishi Gason pun tertidur ya lepas sahur ni. Sailesh, I gave you a task, right? Call them or not? Sailesh? Sailesh also went missing already. Sailesh? Then whom to give? So, Suhasan? 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 Also slept off already. All missing already. Who else here? Sailesh? Suhasan? Don't have. Okay lah, I put attendance 0. So for Tenarasan, Rishikesan, Sailesh also. So Hassan, I'm calling y'all. Y'all are not responding. So I put 0. Okay. So I hope you understand this lecture, Okay, I give you 5 minutes rest. And I cannot ask you whether you all had breakfast or not. Semua dah sahur ke tak? Alia? Sahur tak pagi tadi?
Dah, madam.
Dah. Sorry lah, I terminum depan you orang teh. Tak apa kan?
Tak apa, madam.
Tak apa, I forgot. Sorry. Okay, so I give you 5 minutes rest. We will continue back at 9:15. Okay, is it okay? A bit more. I'm not going to drag for you all. Try to absorb whatever I've taught you. I will send the notes later. Okay, I will send the notes later. And I want you to understand. So far, any question? Because I'm going to go to next part already. If you don't have any question, I'm going to go to next part already. The next part will be on we're going into this one, functional dependency. So any question? Grace, anything? Any question, Grace? Grace? Why are all missing today? Can you hear me, Grace?
Yes, madam. Sorry.
Any questions so far? Clear?
Yeah, madam.
Never mind. I will also send you all the video.
Yeah.
Share, you all please put a hi or tell your name in your Telegram. Any one of you, maybe Alia. Later I download in the Telegram. You can broadcast it to other students in your class. Okay. And okay, you can go break just a few minutes until 10:50. Hello, are you all there? Mana yang tadi hilang-hilang semua? Semua hilang ke? Ada lagi ke?
Ada
Hmm?
madam.
Ada.
Ada
ah?
madam.
Ada madam.
Ada. ah? Brittany. Brittany. Yes, Brittany. So when are you all coming? Actually second sem is coming late, right? Hari bulan berapa? 5. Bila?
5, 13. I mean, 13, 13, 30, 30. Yeah, 30.
30
By
ah?
30.
30
Yeah,
ah?
very late, very late.
It's almost to your
Almost June already. Yeah. Almost
Yeah,
June.
you're coming on 30th. Let me see. Rugi lah you Brittany.
Yeah.
You datang lepas tu kena balik. You orang ada short sem tak?
Huh?
Short sem ada tak? Short sem. May sem.
This sem is short sem, right?
No, this is long sem.
Ada madam.
Ada.
Ada okay. Then okay lah, you can stay back. Sebab semester akan akhir bila you tahu tak? Semester akan akhir 3/6. 3 hari bulan 6. Dah habis dah. So you dah habis lah, you datang untuk peperiksaan sajalah, that means. So I won't have chance to see all. I don't know where they're going to do the final. So we see. I don't know whether I can meet you all or not. But your final starts from 4th May. I mean 4th June. Wait. Okay, so 30th lah, you all will be coming only for exam. After that, you will have short sem in that case. Then you all can just stay back for your short sem. Cuti lama tau semester ni. Cuti dia 9 minggu tau. So, you orang akan buat satu semester dalam tu. Mungkin 2 ataupun 3 subjek you orang akan buat. So, you orang boleh grad dalam 2,5 tahun lah sebab tu dia orang buat short sem ni. Banyak dah keluar internet masalah ke? Okay, kita akan pergi kepada continue ya. Are you all okay? Sailesh, came back already or not? Still out dah?
Yes, miss.
Just now I've been calling you all. Where you all went?
Sorry, miss. Didn't hear.
Hey, went for breakfast is it? What breakfast was that?
No lah, miss.
No.
Was here only.
It's you only. Okay, you managed to call Tenarasan and Rishikesan or not? I gave you a task, right?
No reply, miss.
All must be sleeping lah. Ni pun lepas sahur kau tidur. Okay, so we are going into new one. Okay, you all know why we need to do normalization. As I told you, this form, let's say you are the project manager, someone give you a task to do this form, they want it to make computerization. So you want, the only thing that you will strike your mind is to develop a database for it. Okay, so in order for you to do database, you have to do normalization for the form so that you can get something like this, where you get few entities with attributes. You have to assign the attributes according to this form. Okay, this is also going to be your project. In future, this is one of your case study one. You must know that this is going to be your case study one. You have to, this is the base before you can do the programming, before you can create the table, you have to do it, you have to do normalization first. You have to create it into few tables that you feel very comfortable. With that table, why do we need to do normalization? We don't want any anomalies to happen like this. Okay, we don't want any anomalies to happen. Okay, that's why we are doing normalization. We have 3 anomalies. We don't want this to happen. Okay, we don't want data redundancy also. That's why we are doing all this. Okay, we don't want your table to be all this. So there are few steps. There are few steps that you will do. Okay, So the first step will be first normalization, second will be second normalization, third normalization. Okay, so you will be doing that. I will teach you tomorrow on that one. Okay, so we are going next. Next, once you are done this, so I will be teaching you on functional dependency. There are three dependencies that you should know. One is functionally dependency. You don't see this note. This note is very confusing. I will show you a very simple notes. That means functional dependency is a constraint that determines the relation of attribute, one attribute to another attribute in database, functionally dependent. Let's say, yeah, let's say X, the arrow shows functionally dependent. X dependence, the functional dependence of X on Y is represented by X to Y. Let's understand functionally dependency in database management. Okay, so that means, wait, dependency of X and Y is represented. Okay, let's see here. In this example, you understand the first one that I'm showing you is functional dependency. We have three dependency. One is functional, another one is partial. Partial is not in the syllabus, but I'm going to teach you transitive functional. Correct the spelling. Let me just transitive. Okay. So these three you need to know. Okay, one we start with functional. Second, we start with partial. This will be 1. This will be 2. This will be 3. Okay, this is the three important things that you should know so that you can do the process here. The process here, from the table, we make it smaller table. We need to know all these three because why? Because why you see here. To do the normalization, we have few steps. This is the normalization steps. First step, second step, and third step. First normalization, second normalization, and third normalization. Okay, you see this one. So to do the first normalization, eliminate repeating group. Second, eliminate partial dependency. Eliminate transitive dependency. You see this? Can you see this? That's why you have to learn. You have to learn all that. Okay, you have to learn all this functional partial. This is partial. For second one, you shouldn't have partial functional dependency. For third one, you shouldn't have transitive dependency. You see, this is first normalization. This is second normalization. This is third normalization for. Okay, so for second one, you shouldn't have partially dependency. For third one, you shouldn't have transitive dependency. For first one, you must eliminate repeating group. Okay, you must change the repeating group. Okay, so now we are going back. I will start with the functional dependency first. Okay. Okay, you can realize that constraint that determines the relation of one attribute. Okay, so we see here in this example, we know the value of employee number. What is functional dependency? If we know the employee number, we can obtain employee name, city, salary, and etc. By this, we can say that the city employee number. Okay, the city employee number and salary are functionally dependent on employee number. Okay, do they have anything to write? Okay, you understand or not? In this example, we know, you see, if you know employee number, you know employee name, you know salary, you know the city. So that means employee name, employee salary, and city are functionally dependent on employee number. So that is what we call functionally dependent. Then we have partial dependency. Partial dependency, we see how it happens. In above table, we have partial dependency. Let us see how. The prime key attributes are, so we know this is the primary key, and we know this is the primary key. Okay, student ID, unique ID of the student. Student name, name of the student. Okay, okay, and we know this is primary key, this is primary key, and project name, name of the project. Okay, so we have two primary key in one table. Okay, what we do is we break the table into two. Okay, as stated, the non-prime attribute student name and project name should be functionally dependent on part of candidate key. Okay, to be partial dependent should be functionally. So these two are partially dependent. The student name can determine student ID, project name can determine project number. You see, we must only have one thing in the table. We only must have functionally depend. We must have only functionally dependent, okay, in every table. One, if you give employee number, you should be able to give this. Not like you give student ID, you can get, or you can get student name. You give project ID, you can get project name. Cannot be like that, because this is also primary key, this is also primary key. The best part is in partial dependency, break the primary key, because the primary student ID determines student name, project number determine project name. So you break it. We don't want two primary key in one table. You see, it must be like this. One primary key to determine the employee name, salary, and city. Here we have one primary key to determine the student name. We have one primary key to determine the project name. We don't want that. So what we do, we break it. We break one, we break into student ID, project number, student name. Okay, we can have two primary key, doesn't matter. Okay, but we don't want, we want the student project name to be different. This one will be, if you give here, then this one will become foreign key and also primary key. Okay, or no, wrong. What is it? This one will be primary key, this one will be primary key, this one will be foreign key. You know, you understand? This one we declare it as foreign key. So this one will be, you see, this is a foreign key, this is primary key. So we remove the partial dependency, which is the violating second normalization. We don't want to have two primary key in one table, so we separate it. And we maintain the project number here because we need it. It's like this is like a child table. This is like a parent table. So we should know which parent is here, which parent is here. So that's why to remove partial dependency, we have to remove this partial dependency. You see, from here, we make it into two more tables. Okay, because we don't want to have two primary key there. That is called partial dependency, and it violates the second normalization. It must be like this. What is it called as? Functional dependency, where when you know this is your primary key, this is your primary key, when this primary key tells you your employee name, salary, and city. So city, salary, and employee name functionally depend on employee number. Okay. So you must have functionally dependent in a table, but you shouldn't have partial dependency in any table. So you have to break the table. If you see here, student ID will determine project number and student name. Okay, but the project number, who is the project, what is the project name? We have another parent key will determine that. Okay, so that's how it's supposed to be. You can have one primary key, one foreign key, but not both primary key. Okay, so this one all, you leave it like this one all in different terms. I'm teaching you in a very, very simple, very simple way. Okay, so this one all is a bit difficult for you to understand. So to achieve, you see here only, to achieve three normalization, eliminate the transitive dependency. So as I told you, we have three dependency. I already taught you two. We have one functional dependency. This one you must have in every table. Partial, we have to eliminate in second normalization. And third one we have to eliminate, that is what we call uh, transitive normalization, transitive dependency for third normalization. So we're going to eliminate that. Okay, we see here. Okay, a transitive functional dependency is when changing a non-key column might cause any of other non-key column to change. Okay, example, changing the non-key, very simple way I'm teaching you. You see, changing the non-key full name may change the salutation. Let's say you are changing this to N. So what will be the salutation? It must be Miss, correct or not? So let's say you change name, the salutation shouldn't change actually. You see, when you change this column, this is your primary key. Okay, this one all normal column. Okay, so when you change and salutation also change. So you have to break this one. Maybe you have to put a column here. Maybe a gender. Okay, female, male, female. So you just put here gender salutation. So if female, Miss, male, Mr. So you break the table. Okay, so that's why a transitive functional dependency is when changing a non-key. Changing non-key means it's not a primary key, it's normal attribute. Okay, normal attribute. Okay, normal attribute. So when you changing normal attribute, like Robert Peel, we don't want Robert Peel, we are putting N, might cause any of the other non-key columns to change. Okay, so when you change it to N must be Miss. So what we suggest, you take it out and put it in a different table. It could be a weak entity because it might not have any, it don't have any primary key, doesn't have any primary key, so it is a weak entity. But never mind, we also need weak entity to solve this type of issues. Okay, we don't want this non-key to change another non-key, the normal attribute columns. Okay, so this is functionally dependency. So I already told you this one, when you eliminate this, it becomes the normalization. Okay, so what you need is always, you must always have functional dependency where, example, one primary key and one primary key determine all the three attributes, non-key attributes. Okay, partial dependency, if there's two primary key, you have to break it. We don't want that. Okay, that is partial dependency. That one, we don't want partial dependency in two normalization. And third one is transitive dependency. Where transitive dependency, got anything simple way? No, you just see here. There. To achieve three normalization, eliminate the transitive dependency. What a transitive dependency? A transitive dependency is when changing a non-key column might cause any of the other non-key columns to change. Okay, example, other example also is here. If we find that the above student detail relation student ID, so we know this is the attribute, this is the entity or relation name, student detail, and this is the primary key, and all these are non-key attributes. Okay, we find that above student detail, student ID is the key and only primary key attribute and only primary key. We find that city can be identified by student as well as zip itself. Neither zip is super key nor city a primary attribute. Okay, additionally, So there exists transitive dependency. Okay, to bring this relation into third normalization, we just take out zip city. We just take out the zip is neither super key nor city. Okay, the same thing lah, same thing. The it's also something like partial because your zip, your postcode is also unique, can be unique, but here they never tell unique. Okay, so when you change zip, it will also affect the city. So that's why they take out the zip, they put it as a primary key here, and super key no, or you can make it as a foreign key here. This one becomes primary key if you want to do that, if you want to break, or you can just leave it. You just leave it here, you just leave it, and this one will become weak entity, weak entity, just to break this one. Okay, so these are we break the relation into two relation as follow, third normalization. Okay, so I'm done with this. So I'm going to see your activity. Wait, your work activity. Orang puas lah dengan markah quiz 2. Okey lah? I tengok pun okey je quiz 2. Senang lah quiz 2. Kelas? Humaira, senang lah quiz 2.
Okey je.
Okey je. Okey lah. Compare dengan first one, second one easier. Tengok soalan lah. Soalan final pun macam tu juga. Nanti I akan bagi soalan final lah. I ada. Nanti I akan scan bagi orang. Soalan final bukan SEM ni ya. SEM dulu-dulu punya you tengok. Okay, wait answer, you don't see the answer, we see this one. Question. I haven't marked your lab task one, later I mark lah. Okay, because I already discussed the answers, right? So I'm going to give you exercise because I'm not going to start with first normalization, second normalization, and third normalization now. So definitely I will, as usual, I will give you activity to do, but no need to send today. Okay. Let me go through it. I'll give you the notes. I'll put in the WhatsApp the notes. Tomorrow, esok ada apa-apa tak? Esok ada okay, we are done ya. Esok ada apa-apa khusus ke? Boleh buat ada. Kita tak belajar ni lagi, nanti kita belajar bahagian ni. Adalah assignment untuk ni, tak apa. You are very lucky you don't have. Yang ni second part. Wait, let me check. We have or not? No, don't have. Wait, let me check. ERD is the second part. Oh yeah, don't have. Aduh, last time. Normalization. Don't have. Okay, never mind. I'll pass it to you. Okay, never mind. I think I will end today's class. Okay. I think you all must be very happy to end today's class. You have any questions so far, class? If you don't understand, or is it very difficult? I just told you what's the purpose of us do the normalization. We haven't started into normalization. So why we need to do normalization? Because we don't want any anomalies happens. We don't want any insertion anomaly, deletion anomaly, and we don't want any modification anomalies, and we don't want redundancy tables data. That's why we need to do normalization. As people give you a project, as I told you, if people give you a project like this, then you have to do into few tables, like how I show you just now. You have to do it into few tables So that is process called normalization. We have three process: first normalization, second normalization, third normalization. So you need to have functional dependency. That means when you have one primary key, the other attributes depends on that primary key. But you have two primary key in one table, that means you have to break the table. We don't want to have two primary key. That is called partially dependency. We don't want to have two primary keys, so we break it. And then transitive dependency also, we don't want to have transitive dependency. Okay, where a non-key, we have a non-key attributes. If you make changes, another non-key is also affected, so we don't want, so we break the table. All these will be break. Okay, so that are the method of breaking the table. You understand or not? So far okay or not? Tell. I continue the class. Divya?
Madam.
Okay, Divya?
Okay, madam.
Okay, never mind. I will send you all this video and these notes after this class. So can you all tell something in the Alia? Can you WhatsApp me in Telegram me? Okay.
Okay, madam.
Okay. So if you don't have anything, I just wanted to show you all this. Wait, I just wanted to show you this part. I'm telling you, it's not easy. I don't expect you understand just in 1.5 hours that I taught you. I will repeat to you if you don't understand. If you don't ask me, it's quite difficult lah. Okay, even it took me very long for me to understand. You know why? Because I'm not an IT lecturer. I'm not an IT lecturer. When I came here into this poly, immediately they gave me this subject to teach, and I was very much interested in that database. So I thought my core subject is always computer system architecture, which I really love to teach, but this time I didn't get. Okay, but database is another of my passion. I love database. It's a very interesting subject. So I would like to share whatever I know with you all. Okay, so if you don't have anything, we will end the class for today. Is it okay? Is it okay, class?
Okay, madam.
Okay,
Okay,
bye.
madam.
See you all. Have a nice day. Have a nice break.
Thank you, madam.
Thank you, madam.
Bye.
Thank you,
Thank you,
madam.
madam.
Thank you,
Thank you, madam.
Okay.
Thank you, madam.
Okay.